Hi everyone and welcome back to Maths and Physics to Mr. Simons. Today's lesson on energy and change, looking at the third variation of 4, and now it's from the November 2018, given the equation, reaction plus a exothermic graph, and the second one it was a endothermic graph. Right, so I hope you like and subscribe so that you can see all variations here on my YouTube channel. Right, so let's look at the question. Following reaction between ammonia and oxygen takes place in a closed system at constant pressure and temperature. 4 moles of ammonia react with 5 moles of oxygen to form 4 moles of nitrogen oxide and 6 moles of water. 7.1, by now third variation should see very common question. Define the term activation energy for 2 marks. So if you study and know this definition and they ask it, you have 2 marks in the back. Give a reason why this reaction is exothermic. Calculate the heat of the reaction, so that's delta H given to you in the drawing. Draw the graph and indicate to the dotted line the effect of a catalyst. So the previous one we wanted to know how we use a catalyst. Now to draw the effect of the catalyst. Right here we've included Avogadro's law in words. Included calculating using a table, basic Rice table, and then we've also included calculation of empirical formula in this question. We give you percentage of each element. All right, so let's look at the questions and answers. So define the term activation energy. So whenever we say activation energy, minimum energy, no? So the minimum energy needed for a reaction to take place. So the minimum amount of energy I need to take in from there to there to ensure that particles will break up and recombine to form something new when we release the energy. Give a reason why this reaction is exothermic. So you see from 400 to there, the amount of energy absorbed there is less than the amount of energy I gave away. Right, so more energy is released than absorbed. So more energy released from that point than what I took in. Therefore, exothermic. In short, my reactants is higher than my products. All right. Calculate the heat of a reaction. So delta H should always be H products, which is there 183,3 minus H reactants, which is 400. So 183,3 minus 400 gives me negative 216,7 kilojoules per mole. Because delta H is negative, the reaction is exothermic. Alright, look at the following reaction. Let's say we have to redraw the graph, indicate with the dotted line the effect of a catalyst. So catalyst lowers the part 2 activation energy, or it lowers the activation energy to ensure that the minimum energy required for the reaction to take place is even less. So there, when I draw the dotted line, I have to lower the curved line and lower the activation energy. Alright, so you see there, and I compare, it is lower. So 1 mark for the dotted line, 1 mark for the activation energy being lower. Next question. Following reaction takes place, Avogadro's law in words. 1 mole of any gas occupies the same volume at the same temperature and pressure. 1 mole of any gas occupies the same volume at the same temperature and pressure. Now 7.6, if 6 decimeter cubed of ammonia and 9 decimeter cubed of oxygen are used, calculate the total volume of gases at the end of the reaction. Right, so there I have 4 moles, 5 moles, 4, 6. Initial volume I had 6 decimeter cubed and I had 9 decimeter cubed. In the initial stages, nitrogen oxide and water hasn't been formed yet. So therefore 0 and 0. Right, now we use up all the ammonia. We're going to change in volume, minus 6, that gives me 0 final volume. Right, now if I stay with the ratio, so to get from 6 to 9, Now divide by 6 times 9. So here, 6 divided by 6 times 9, and the ratio would give me minus 7,5. There, 0 would become plus 6, based on the fact that it's 4 and 4. So there, to go from 4 to 5, there 4 and 4 would both be negative 6, plus 6 for products. And there 6H2O would become plus 9. Alright, so using the ratio there, 1 mark. So 6 minus 6, 0. 9 minus 7,5, 1,5. 0 plus 6 would give me 6. And 0 plus 9 would give me 9. So my total volume is 9 plus 6, which gives me 15, plus 1,5, which gives me 16,5. So in short, to go from 4 to 6 there, you see 4 and 4 is 6, so therefore plus 6 divided by 4 times 6 would then give me 9. So that's 3 over 2 times 6. 6 times 3 gives me 18. 18 over 2 would give me 9. To go from 4 to 5, I have 6. Right, so there's 6 divided by 4 times 5. Right, that gives me 5 times 4, which is 20, divided by 6, which then gives me 7,5. Right, so hope you follow. Right, so my total volume 16,5 decimeter cubed. Next question. The following reaction between that takes place. The reaction above is the first step in the manufacturing of an acid. This acid contains 1,59% hydrogen, 22,2% nitrogen, 75,2% oxygen. Determine the empirical, that E should be I, formula of the acid for 5 marks. Right, so using N equal the mass divided by molar mass. For hydrogen, we have 1,59%. So this percentage adds up to 100. So we're going to change percentage to gram. So that becomes 1,59 gram, 22,2 gram, and 75,2 gram. Right, molar mass for hydrogen, rounded off to 1 there. Nitrogen, 14. Oxygen, rounded off to 16. So 1,59 divided by 1 gives me 1,59 mole. For moles of nitrogen, 22,2 divided by 14 gives me 1,5857 mole. And for oxygen, 76,2 divided by 16. 1 mark for correct values. Alright. Then from there, to get the ratio of hydrogen to nitrogen to oxygen, we're going to divide by the smallest value of the 3, which in this case is 1,5857 mole. So 1,59 divided by 1,5857 gives me 1. The anything divided by itself gives me 1. 4,625 divided by 1,5857 gives me 3. So my ratio is 1:1:3. So I have HNO3. So my empirical formula is HNO3 for last mark. So that's 3, 4, 5 marks. So hope you follow, understand. Next question, we'll also have empirical formula, right? God bless. Bye.